Okay, so we're going to talk about systems of linear inequalities, linear inequalities in two variables. So the solution set of a system of inequalities is the intersection of the solution sets of the individual inequalities of the system. So this will be similar to solving systems of equations, but we'll be doing them with inequalities instead. So to find the solution, we're going to graph both inequalities and find the intersections of their graphs. So we would be looking at graphing the two inequalities and finding the point that they have in common. All right, so a corner point of a solution region is a point in the solution region that is the intersection of two boundary lines. It is an intercept that then it is the point of the intercept. If it's the intersection of two lines, then solve the system of the two equations to find the corner point. So here, depending on where the solution is, we would look at the intercepts right there. And then this, we would have to find that. So we would have to find that solution point is at 2, 4. Now the solution is bounded if it's enclosed on all sides. It's unbounded if the solution region can't be enclosed on all sides. So we only have a couple of problems here that we're going to work out. Our first one, and all three are on our handout. So we're going to graph the solution of the following system. We're given two equations, and then we'll do some more on the next two problems. All right, so we are looking at, this is 5.2, example 1. So we're going to graph the system. My dying pens, put that over there. And we're given x minus 5y greater than or equal to -5, and 3x plus y less than or equal to 4. So we're going to do the same thing we've done in the previous sections. We're going to find the x-intercept, the y-intercept, and do the test point. So I'm going to do x minus 5y greater than or equal to -5 first. So we're going to find the x-intercept, where we set y equal to 0. So x minus 5 times 0 equal to -5. We get x equals -5. So that will give us -5, 0 for our intercept. All right, our y-intercept, where our x equals 0. So 0 minus 5y equals -5. So -5y equals -5. Divide both sides by -5. Y equals 1. So 0, 1 is our x-intercept. So we've got this one, and we've got this one to graph. And then we'll do the test point. Test point is still going to be 0, 0, because it's the easiest to plug in. So we're going to have 0 minus 5 times 0 greater than or equal to -5. Well, that's going to get us 0 minus 0, which is 0, greater than or equal to -5. 0 is greater than -5, so this is true. So it will include 0, 0 in solution. Okay, now let's do our second equation. We have 3x plus y less than or equal to 4. So x-intercept, y equals 0. So 3x plus 0 less than, just equal to 4. So 3x equals 4, divide by 3, x will be equal to 4/3. So 4/3, 0 is our x-intercept. So our y-intercept, x will be equal to 0. So 3 times 0 plus y equal to 4, y equals 4. So 0, 4 is our y-intercept. And then we'll check our test point. Again, 0, 0, because it's easy to plug in. So we have 3 times 0 plus 0 less than or equal to 4. So 0 less than or equal to 4, that again is true. So includes 0, 0. Okay? And recall, both of them have an equal to on it, so the lines will be solid. All right, so we're going to draw a graph. We've got -5 for our x, 1 for our y, 4 for our y, and 4/3. So we're going to need a small side of our graph on the x positive, but we'll need more on the x negative. And we'll need a good amount on the y positive, because we've got to go to 4. All right, so let's draw our graph. And something like this. So 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 1, 2. All right, so we have our x at -5, our y at 1. So this is our first line, and it'll be solid. And this is our x minus 5y greater than or equal to -5. All right, then I'm going to draw my second line. My x is at 4/3, so that's a little over 1. And my y value is at 4. And this one is my 3x plus y less than or equal to 4. In both cases, the 0, 0 was in our solution set. So this is going to be my answer right here. It's be shaded there. So that's how we're going to graph our inequalities. Now we've talked about a couple of things. This graph is not bounded because it's not found in, it doesn't have sides. If we needed to find the corner point, we would have to solve the systems of equations to get there. We're not doing that on this one. We're going to do it on the next one. But just to talk about some of our vocabulary that we talked about. So not bounded because it's not closed in on all sides. All right, let's go to example 2. So for example 2, we're told to solve the system graphically and indicate whether the solution region is bounded or unbounded. Find the coordinates of each corner point. Now, with these, if they are telling you to use a calculator, you can plug these into a calculator. If you don't have a graphing calculator, you can use Desmos and plug in the equations with Desmos and find some of this. But I want to show you how to do it on paper so that you can do it for an exam, because on an exam I'm never going to ask you to do it just graphically on a calculator. I'm going to make you show me what you got to do. All right, so here we have the equations. We're going to solve the system. And we have 7x plus 5y less than or equal to 35. And we have x greater than or equal to 0 and y greater than or equal to 0. And that tells us we're going to be in quadrant 1, and those things are going to be positive. So let's go find our x-intercepts. We only need to do that on this because on these two, there's not a lot to do with that. All right, so for our x-intercept, of course, y equals 0. So we have 7x plus 5 times 0 equals 35. 7x equals 35. Divide by 7. X will be equal to 5. So we have 5, 0. For the y-intercept, we have x equal to 0. So 7 times 0 plus 5y equals 35. 5y equals 35. Y equals 7. So 0, 7. And then, of course, we're going to test our 0, 0. So 7 times 0 plus 5 times 0 less than or equal to 35. So 0 is less than or equal to 35. This is true. So 0, 0 will be in shaded area. Okay, which also means it's in the solution. Alrighty. So let's graph what we know and then figure some stuff out. So we've got to go for our x value to 5. Our y value needs to go to 7. And we're only going to be in quadrant 1. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So we're going to graph our line. It is solid because we had an equal to part. And our 0, 0 is in our shaded area. So this part in here, this will be our shaded area. Okay, now because this is solid on all lines, that is bounded. So the solution is bounded. Versus the last one was unbounded. And we're going to discuss the corner points. So for the corner points, our corner points are going to be the x-intercept, the y-intercept of 0, 7. We have 0, 0. And we have 5, 0, which is our x-intercept. I don't know why I keep saying them backwards. So we have the x-intercept, the y-intercept, and our 0, 0. Those would be the corner points on it because we don't have anything else anywhere. Like they're not overlapping lines. Okay? All right, let's go to example 3. So example 3, which is our last example for this section, says to solve the system graphically and indicate whether the solution region is bounded or unbounded, find the coordinates of each corner point. So this time we have 4 things. The x and the y part, again, is just to tell us our answer will be in quadrant 1 because they have to be positive. But we have to graph 2 lines now, 2 inequality lines. And they both are going to be solid again because we have equal to's. All right, so we're going to solve the system. And we have 3x plus y less than or equal to 9. 3x plus 2y less than or equal to 12. X is greater than or equal to 0, and y is greater than or equal to 0. All right, so for our first equation of 3x plus y is less than or equal to 9. First thing, x-intercept, y equals to 0. All right, so we get 3x plus 0, just equal to 9. So 3x equals 9, divide by 3, x equals 3. So our intercept will be 3, 0. Our y-intercept, where x is equal to 0, will be 3 times 0 plus y equal to 9. Y equals 9, so 0, 9. And then we're going to do our test. We're going to test 0, 0. So that'll get us 3 times 0 plus 0 less than or equal to 9. 0 is less than or equal to 9. This is true. And we'll draw a line for the next part. So the next equation will be 3x plus 2y less than or equal to 12. So x-intercept, y equals 0. So 3x plus 2 times 0 equal to 12. 3x equals 12. X equals 4. So we have 4, 0 as our x-intercept. The y-intercept would be x equal to 0. So with x equal to 0, we'll have 3 times 0 plus 2y equal to 12. 2y equals 12. Divide by our 2, and y equals 6. So 0, 6 is our y-intercept, and then we still have to do our test point. So we're going to test 0, 0. So we have 3 times 0 plus 2 times 0 less than or equal to 12. 0 is less than or equal to 12, so this is also true. So now we need to graph. So our high point on the y is 9, and our high point on the x is 4. So I'm going to graph here. One, 2, 3, 4, 5, 6, 7, 8, 9. And we have 1, 2, 3, 4, 5, 6. No, 1, 2, 3, 4. This will be the 6 that we need. All right, and then we have 1, 2, 3, and 4. All right, so for our first line, we have x equal to 3, y equal to 9, and again, they're both got the equal part, so they will be a solid. And for my second line, I have 4, 0 for the x and 6, 0 for, or 0, 6 for the y. And it's true for both here and here, so that tells me this here. So this will be my shaded area. Now, that means I have this corner point, I have this corner point, I have this one, but I don't know what this one is. I can guess by looking at my graph. My graph is not perfect because I hand drew it. Looks like it's at 2, but is it at 3 or is it at 4? I don't know. So I'm going to have to figure that out, because I can't tell by doing that. That's where you could find that on a graphing calculator or Desmos, but you still have to be able to show me that work on an exam, so you need to practice it. So if we're looking at corner points, so for the corner points, we're looking at those intercepts. So we know that it is 0, 6 for the y-intercept. The x-intercept, it is 3, 0, and I know this one is 0, 0. But I have to find this one. So that one, I'm going to have to see where the lines, oops, sorry, you cannot see what I wrote. All right, so for this one, I have to find the intersection of the two. So we're going to solve the system. So for that fourth corner point, I'm going to take 3x plus y equal to 9. And we have 3x plus 2y equal to 12. That's our system. So I'm going to use, and those come from our original lines, but I made them as equal to's, not inequalities. So we're going to solve these like we solve systems of equations in previous sections. All right, so I can get rid of the x's and solve for y. My if I just multiply by one of them by a -1, because then I'll get a -3x. My y is bigger down here, so I am going to multiply by -1 on this one, and this one I will have no change. All right, so that's going to get me -3x minus y equals -9. And then bring over my 3x plus 2y equals 12. The x's will cancel. Y will be equal to 3. All right, so I have the y value. Now, just like we did in systems of equations before, I will plug in y equal to 3. And does it matter which equation? It doesn't. This one's probably the easier one than the second one, but you could use either one, it doesn't matter. So this will get us 3x plus y equal to 3 equals 9. Move my 3 over. I get 3x equal to 6. Divide by 3, x equals 2. So my point is 2, 3, x, y. So now I will come up here and add in my 2, 3 point. So those are my 4 solutions, my corner points that I was looking for. Now, let's go back and talk about, is this bounded? Yes, it is. Solution is bounded because it is bounded on all the sides. Solution is bounded because it's bounded here, here, and by the 2 lines. All right. And that is all of the problems we have for this section.